Okay, now in Chapter 47 we're going to look at conservation and biodiversity. Um, we have what's called conservation biology. This is going to look at all aspects of biodiversity. It's a relatively new discipline. The goal is to conserve the natural resources for this generation and future generations. And we do this by managing biodiversity for sustainable use by humans. We're talking here about the variety of life on Earth. We need to keep a good variety of life. We don't want to lose any of the types. It supports certain ethical principles. Um, it's desirable to have biodiversity for the biosphere, and so it's desirable for us. A high level of biodiversity influences the stability of our ecosystems. Also, we don't want any extinctions because 10 to 20% of existing species will most likely become extinct in the next 20 to 50 years. That's not good because we are the ones causing that. Complex interactions in the ecosystem support biodiversity, and this is desirable. And biodiversity is brought about by evolutionary change, and it has value in and of itself. Simply put, biodiversity is the variety of species on Earth. It's estimated that there's 10 to 50 million species currently, and when we look at endangered species, these are in peril of extinction, like the giant panda and the hawksbill turtle. A threatened species, they are likely to become endangered in the near future, like the northern spotted owl or the coho salmon that you see. And then, I don't know what that says. Genetic diversity. Just one second. I'm sorry. Genetic diversity is the variations among the members of the populations, and this is more likely to, you're more likely to have some that can survive if an ecosystem changes, if you have a lot of genetic diversity. For instance, back in 1984, there was a citrus canker that developed on the citrus crops, and there was not a lot of genetic diversity, so a lot of the citrus orange crops were lost because of that canker. The diversity of the ecosystem is dependent on how the species in that area interact, and we also need to look at landscape diversity because there's a lot of interactions in the species in an area. Here we see that we believe we have about 240,000, or we know that we have about 240,000 plants that have been identified, 900,000 insects, 280,000 animals, and then you see the smaller numbers there for the fungus, the protist, the bacteria, and archaea. There's only 1.75 million species that have been identified so far. But it's important to remember that it's not evenly distributed throughout the biosphere. It is higher at tropical areas where they have warm, moist weather with a long, forever growing season. The hot spots, which is only about 1.4% of our Earth's land area, would be the Great Barrier Reef is an example. The Madagascar is another example of a hot spot, and the Cape of South Africa. The direct value, the species perform services from which humans derive economic value. There's medicinal value. There's agricultural value, obviously, as far as using it for pest control. The pest predators are used to control them, and of course pollination. Also, consumptive use value. We use timber from wood and skins, and a lot of hunting and fishing feeds a whole lot of people. So you see there's a lot of value directly from the wildlife in an area. Indirectly, it doesn't really have a way to measure it by economic value, but it helps just by existing because it aids in our biogeochemical cycles and waste disposal, prevention of soil erosion, regulation of the climate. All those things are an indirect effect. This is a good place to stop, so the video won't be too long. We'll pick up next with this slide.